Hello and welcome to the Full Stack Data Engineering Masterclass. I'm truly excited to have you here because this is not just another tech course. This is a career transformation journey brought to you by Gayu IAS&Tech and powered by Lare Cloud Solutions, designed to make you industry ready with hands-on, real-time learning. From day one, we go beyond theory. Every concept you learn will be tied to real world business scenarios, the kind of task you all actually work on in your job. You will not only master the technical foundations like Python, SQL, PySpark, and cloud platforms, but you will also become a true full stack data engineer. That is, one who builds scalable data pipelines, deploys on the cloud, designs APIs and data apps, and knows how to monitor and automate in live production environments. Most importantly, everything is taught with the sector based projects. One day you'll work on banking data use case, next day you'll all simulate a healthcare analytics pipeline. Over time, you all build a 5+ project GitHub portfolio that demonstrates your skills just like a real engineering on the job. Whether you are aiming to become a professional in the corporate world, want to freelance, or build your own tech product, this course is your launchpad. Let's get started and dive deep into the world where data meets engineering and learning meets opportunity. Welcome once again to the Full Stack Data Engineering Masterclass. Now, before we dive into the tools and technology, let's answer a fundamental question. Who is a data engineer? Why is this career so important? And where exactly is it used? So let's break it down. The three W's of a data engineer. That is, first one is what is a data engineer? Here, a data engineer is the technological architect behind the scenes. That is, they are responsible for designing, building, and managing data pipelines, data systems, and databases. Think of it like this: a data scientist or an analyst needs data to generate insights, but who collects, cleans, transforms, and delivers the data? That is the job of a data engineer. Data engineer is the builder. Without the builder, there is no AI, no dashboards, no insights. You are the foundation of all data driven decisions. Now, why choose data engineering as a career? Because this is one of the most high growth and future proof roles in tech industries. Massive demand across the world, high paying roles from startups to tech chains. It is the backbone of every AI, ML, and analytics systems. Whether you are interested in finance, healthcare, e commerce, or even entertainment, your company needs a skills data engineer. Next, where is the data engineering is used? Everywhere. Let me give you some real examples that we all simulate in this course. Banking and finance, you all work on a loan risk and data pipelines. E-commerce and media and OTT, healthcare, logistics, educations, manufacturing, even in governments use data engineering daily. In this course, we will cover multiple sector specific labs and projects so you are comfortable switching between the domains. So remember, this data engineering is the invisible engine behind every smart business. And starting today, you are going to learn how to become one of the most valuable and powerful tech professionals in today's data driven world. Now, 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 in this course, what you learn in data engineering course, now that you understand what a data engineer is and why this role is so important, let's talk about what exactly you all be learning in this course. At Gayu IAS and Tech, powered by Lare Cloud Solutions, this is not just a theoretical class, this is a complete transformation program, a journey that will take you from absolute beginner to a fully skilled, job ready full stack data engineer. This course is carefully designed to give you exposure to the entire modern data stack, the same tools used by top companies like Amazon, Google, Netflix, and HDFC Bank. By the end of this course, you will gain three powerful assets. The first one is the technical skills. In the technical skills, you'll become expert level in Python, SQL, and PySpark. And later, you'll be become in real world data tools like you'll be using like real world data tools like Kafka, Airflow, DBT, and MLflow. And you'll get a hands on with cloud platforms like AWS, GCP, and an Azure. Later, you'll build an APIs, deploy with Docker and Kubernetes, and manages the CI/CD pipelines. And after that, you'll be learning to monitor the production systems using Prometheus and Grafana. And after the technical skills, you'll be get exposure in real world project experience. That is, every topic includes lab practice using real business scenarios. For example, you all be given a Jira style task from a banking firm to clean customer data or from an e-commerce sites to optimize product analytics. By the end of this course, you'll all complete the 5+ sector specific projects that are fully GitHub ready. Imagine working on a fraud detection pipeline for a finance app or a real-time health monitoring dashboards for an hospital or a customer retention model for an OTT platform. These are not fake projects. These are exactly how engineers work in real jobs. And third, career readiness. We will optimize your resume and LinkedIn profile, help you build a public GitHub portfolio that recruiters love, conduct one-on-one mentorships, mock interviews, and even provide referrals and job support. You all be ready to apply confidently, interview powerful, and start freelancing if you choose. This course is not just about learning tools, it's about building real engineering muscle, creating a job ready profile, and getting you placed. So, now let's move on to the full roadmap of our learning, the 9 modules that will take you from where you are to where the industry needs you to be. Here, now, we are officially begin with the module 1, programming with Python, followed by web scraping. This is your core foundation, the language you all use in the almost every project as a data engineer. But again, we are not here to just learn Python. We are here to apply Python like a real engineers working on live projects. Here in part one, we all learn about the Python programming. Let's say you just joined a Smart Bank 360, a digital finance company as a data engineering trainee. Your team lead assigns you a Jira task like this. Create a script to define and validate customer information using the correct Python data types. That's where we began. You all learn and apply. The topics here you are going to learn are variables and data types like int, string, boolean, float, list, and dictionaries. And also you learn about the operators and expressions, loops and control flow, con- functions and modules, object-oriented program like classes, objects, and inheritance, decorators for reusable and scalable logic, multi-threading versus multi-processing for speeding up tasks, asynchronous programming using async and await, type annotations and MyPy for type safe code. All this we taught with examples using VS Code, followed by hands-on code challenges. And coming to the part 2, web scraping with beautiful super. Now imagine your next task at the smart bank is scrape a real-time loan interest rates from a third-party finance website. Convert them into a structured format for internal analysis. This is where the web scraping comes in. In web scraping, we all learn like HTML structures and stacks and how to navigate the HTML documents, use of beautiful soup to extract elements, parsing tables, links, and nested tags, cleaning and transforming web data into usable formats. You all build a script that collects a dynamic interest rate info, saves it in a JSON or CSV format, and runs on a schedule. Here in sector base, here you won't stop with just one use case. The next day, you'll all switch domains and apply your Python as a scraping skills to a healthcare sector scenario. For example, scrap WHO COVID-19 statistics and visualize daily case trends. This way you build skills across multiple sectors, learn to write reusable production and ready code, gain experience that mirrors real job tasks. By the end of the module 1, you will understand Python end to end, write efficient clean code in Visual Code, scrape clean and structure web data, handle basic sector tasks just like in a real engineering job. Be prepared to answer the interview questions related to Python data types, classes, web scraping, and async process. Coming to the module 2, in module 2, you are going to learn the module 2. Now that your Python foundation is strong, we move on to the tools that every engineer uses daily to work with teams, automate workflows, and manage projects. That is in module 2. Advanced tools, Git, GitHub, Bash, and Linux. Let's say you are now part of a healthcare data team at the Medicore Labs. Your team lead says, push our latest COVID data scraper to GitHub, create a shell script to run the script scraper daily and set up logs. This is how this is your task, and these tools are how you all do it. So coming to the part 1, you learn about the Git and GitHub collaboration in real time. Here we are going to learn like create and manage branches, handle the merges and conflicts and talks, open pull requests, review the code, and handle the GitHub issues. Use a GitHub actions for an automation. We all simulate this as if you are working in a real time. You all fork the project, create your own branch, make changes, raise a PR for review, merge it into the main repo. All of this will be done inside VS Code and GitHub, just like companies do it. And in the part 2, we are going to learn about the Bash and Linux, automating your workflow. As a data engineer, you all often work inside Linux-based systems, especially in production servers and cloud VMs. Here, you all learn navigating the terminal, file handling, and directory navigation, writing bash scripts to automate tasks, making scripts executable, and scheduling them. You all create a bash script that runs your Python web scraper, logs the output to timestamp log file, sends an alert if data is missing. So here the real world task simulation is you have been asked to automate a daily patient record ingestion pipeline, pull the latest lab test results and push them to your data lake all through scripts. Just like before, first we explain the concept, then we code in VS Code, then we get scenario-based Jira tasks from data sectors like healthcare, fintech, and education. Finally, you answer the interview-style questions about the Git workflows and shell scripting and Linux usage. Coming to the This is about the part module 2. Now coming to the module 3. Here in the module 3, we are going to learn about the big data variety in the real world. For example, in the real world, not all data is stored the same way. As a data engineer, you must be fluent in multiple data storage systems, that is relational data type or relational or document based or graph based or search engines and column stores. So in this module, we all learn about the SQL, MongoDB, Elasticsearch, Neo4j, and HBase. Here, coming to explain this, I'm going to the real world scenario. Imagine you are working at a Shop Pro Insights, an e-commerce analytics company. Your Jira task says Analyze customers' transactions using SQL, store clickstream logs in MongoDB, and search product reviews via Elasticsearch, build customer product relationship in Neo4j, and store huge ad impression logs in HBase. This sounds very complex, right? Now we all break it down and step by step, we'll analyze it. Now coming to the SQL, which is the backbone of the structured data. Here in the SQL, you are going to learn about the core queries, joins and subqueries. And after learning this, you'll go to the aggregate functions and Windows functions and CTCs, indexes and optimizations. Here, while practicing, we write the complex queries to analyze cart abandonment, daily revenue by category, repeat the customers. Use case here. Here, one of the use cases retail analytics for a Black Friday campaign. And coming to the second one, the MongoDB, which is flexible for the document store. Here, you learn about the collections, documents, and the schema-less design query operators like dollar match, dollar group, dollar project, etc. Indexing and performance tuning. Here, after learning this, all these topics you are going to practice on. For example, build a product catalog with nested reviews, price variations, inventory data per house. That is one of the use cases, the dynamic pricing dashboard for a multi-vendor store. And coming to this, after completion of this MongoDB, we are learning about the Elasticsearch, which is in a full text search engine. Here, you'll learn about the indexing the text-heavy data, writing the search queries, relevance scoring, real-time log analytics. Here, you'll practice about the build a review search engine that ranks products by customer sentiment. Here, the customer support team searching complaint keywords across 1 million support tickets. And after completing this Elasticsearch, we'll be learning about the Neo4j, which is a graph database for relationships. Here you learn about the C for query language, nodes, relationships, properties, graph traversal, and visualization. After after learning this, you'll go through the HBase, which is a high volume columnar store. Here, the column families, row key designs, data insertions, and lookups, real time read and write architecture. Here, you'll practice like store and query, add impression logs with millions of rows per hour. And here, the use case is ad tech data pipeline for high frequency ad bidding. Here, the practice flow will be just like before for each systems. You all learn the core concept and practice with the hands-on, and later you'll go through the complete real-world task from different sectors, prepare for interview questions. This is the practice flow for this module. By the end of this module 3, you will learn know which data systems to use for what type of problems. Be comfortable writing queries in 5 major systems. Deliver structured and unstructured data solutions. Have multiple domain experience in e-commerce, customer support, and social graphs and ad tech, etc. This module makes you a true versatile data engineer, someone who can handle any type of data in any type of project. Are you ready to step into the world of real-time data processing next? Here, this is about the module 3. Now here we are going to the module 1. Sorry, module 4. Going to learn about the module 4. Here in the module 4, you are going to learn about, once again, mastering the data processing pipelines for real-time and batch workloads. Here the module 4 is about saying batch and streaming. Here you master the data processing pipelines for real-time and the batch workloads. In the world of, for example, in the world of big data, data does not just sit still. It flows continuously or arrives in large chunks. Now, you are a data engineer, you need to build pipelines that handle both batch processing and real-time streaming efficiently. So here is the part about this module says. In this module, we all focus on PySpark for batch processing and big data transformations, Apache Kafka for real-time data streaming and messaging. Here, the real-world scenarios about this are: imagine you are working at a fin server analytics, a fintech company. Your Jira task reads about process daily transaction logs using PySpark. Batch jobs stream live trading data with Kafka to detect anomalies in real time. It sounds challenging, right? Let's break it down clearly and hands on. First, you'll go in batch and streaming. First, you'll go and you'll see about the PySpark, that is the powerful batch processing on big data. In PySpark, you'll learn about the Spark architecture, R RDDs versus data frames versus data sets. And later, you'll learn about data transformations and actions. After that, writing an efficient Spark jobs in Python, like in PySpark, handling large scale ETL workflows and fault tolerance. Here, while practicing the PySpark scripts, he'll be learning like cleaning and aggregate the daily transactions data, calculate the scores, or generate summary reports for compliance teams. Here, one of the use case was the batch processing for regulatory reporting and fraud detection. And later, PySpark, you'll be learning about the Apache Kafka, that is a real-time data streaming platform. In Kafka, you learn about the Kafka architecture like brokers, topics, partitions, and consumer groups. And later, you'll learn about the producing and consuming data streams, stream processing basics with Kafka streams, or structured streaming, data durability, and fault tolerance. While practicing, you'll build a Kafka pipeline to streamline and stock prices, filter and alter and suspicious trade patterns in real time. That is in use case. Yes, we use this type of use. This Kafka is in use case real time risk management for stock trading platforms. Share about this module 4. By the end of the module 4, you will learn build a scalable batch ETL pipelines with PySpark, design and implement real-time streaming solutions with Kafka, understand the trade-offs between batch and streaming processing, deliver a data pipelines suitable for finance, e-commerce, and IoT domains. And this module equips you with the skills to process any volume of data at any speed, a key capability for modern data engineering roles, ready to power up your data pipelines with batch and streaming mastery. Now, you'll go to this is about the module 4. Now, you'll go to the syllabus of module 5, that is a practical data warehousing. Here, you'll learn about the Snowflake and DBT, which is a modern cloud data warehousing and transformations made easy. As a data volumes grow, as data volumes grow, managing and analyzing data efficiently becomes critical, right? Here in this module, focus us on cloud native data warehousing with a Snowflake paired with modern transformations and automation using DBT. Here, you'll all learn how to store massive data sets, run fast queries, and build reliable data pipelines with maintainable code and automated workflows. Here, one of the real scenario was imagine you are at the retail Pulse Analytics, a company powering data insights for multi-channel retailers. Your Jira task says that centralized sales and customers' data in Snowflake, automate data cleaning and transformations using DBT models, ensure data quality, and provide interactive documentation for analytics. Let's see how it works in practice. The first one is the Snowflake. We are going to see in Snowflake, which is an SQL-based cloud data storage and analysis. Here in Snowflake, you'll be learning like architecture basics, decoupled storage and compute, elastic scaling and cost control, loading data from multiple sources, writing performance SQL queries, and materialized views. Here in Snowflake, you'll all practice about the sorry, load multi-source retail data into Snowflake, and query customer purchase patterns, create data marts for marketing campaigns, optimize warehouse size and compute credits. Here, one of the use case was the cloud data warehouse for unified retail analytics. And after completion of the Snowflake, we'll be learning about the ELT or ETL, which is a DBT. Data, data build tool, transformation and automation. In here, DBT, you are going to learn about writing modular SQL transformation models, managing dependencies and incremental rules, automated testing and data quality checks, generating interactive documentation for stakeholders. After learning all this, you are going to practice like build a DBT project with the cleans raw sales data, joins the customer and product info, runs tests on data consistency, publishes the clear docs for analysis. One of the use case about here in DBT was the automated ELT pipelines with visibility and trust. This is about the module 5. Now we'll look into the module 6. Here in the module 6, we are going to master in the cloud platforms, that is an AWS core services and architectural best practices. Here in the cloud platforms like AWS, GCP, and Azure are the backbone of the modern data engineering. These models focuses on AWS fundamentals for data engineers with a strong foundation in architecture deployment and automation. You are all learn to design scalable, reliable, and cost-effective cloud solutions that power data workloads in productions. So here the real-world scenario is: imagine you are working at the Health Net Analytics, a healthcare startup. Your Jira tickets, your Jira ticket was saying about deploy a secure and a scalable data pipeline on AWS. Use EC2 for compute, S3 for storage, DynamoDB for NoSQL. Needs and design the system for high availability. Let's architect here and automate this solution step by step. Here in the AWS solution, which is an architect concepts, you'll be learning about core AWS services and it's an overview, designing highly available and fault tolerant systems, cost optimization strategies, and security best practices and ARM rules. While practicing, you will be learning the designing cloud architecture diagram for data ingestion pipelines, scalable web apps, disaster recovery startups. Here, the use case was the architecting resilient and cost efficient health data platforms. And the key AWS services here we are going to use are the EC2, which is an virtual servers for flexible compute, S3, a durable and scalable object storage, and later you'll be studying about the RDS, Managed Relational Database, and DynamoDB, fully managed, which is for used for the NoSQL database, and ELB, Elastic Load Balancer, which distribute the traffic across the resources, and the event-driven architectures and automation. ECS and EKS, container orchestration using Docker and a Kubernetes. Here, after learning this, you'll practice it as deploy and configure an EC2 instance running a batch job, or store a raw and process data in S3 buckets with the lifecycle policies. And you are going to set up a DynamoDB tables for low latency lookups using the ELB to distribute load for microservices app, and automate the workflows with an event bridge triggers, and deploy containerized applications with the ECS or EKS. Here, one of the use cases is end-to-end cloud deployment for data pipelines and microservices. This is about the modules 6. Now, you are going to, by the end of the module 6, you will be confidently design and deploy a scalable AWS cloud architectures and manage the compute storage and database services for data engineering needs, automate cloud workflows using the event-driven tools, optimize for cost, availability, and security in production systems. This module empowers you to become a cloud-ready data engineer equipped to build modern, scalable, and resilient data platforms on AWS, ready to take your data engineer skills to the cloud. Are you ready? Now, this is about the module 6. Now we are going to learn about the module 7, which is machine learning from statics to ML models lifecycle, visualize, build, and manage machine learning pipelines. Here, as a data engineer, understanding the basics of machine learning and statistics is a crucial to support data science workflows and build data-driven solutions. This module covers core statistic concepts, visualization techniques, machine learning algorithms, and modern machine learning's lifecycle management using NML flows. Here, the real world scenarios are the imagine you are a smart health analytics working with a medical data and your Jira ticket says that perform expl- exploratory data analysis on patient data, build classification models to predict disease risk, track model experiments, and manage deployment lifecycle with MLflow. Now let's break down step by step. Here you're going to learn about the statistics, which is a descriptive analysis. Here the key statistic concepts like mean, median, variance, and correlation. Understanding the variable relationships and distributions, identify the outliers and data patterns. Here in the practice, we are going to perform a descriptive statistics on patient health metrics and identify the key correlations. One of the use case about the statistics and descriptive analysis is summarizing the health trends and preparing their data for machine learning. After completion of the statistics, you are going to be choosing data visualization. Here you learn visualizing the data with the Metaploit Metaploit library, bar charts, scatter plots, historo- histograms, box plots, pie charts, and after that you'll be building an interactive dashboards with a dash for dynamic explorations. After completion of this theory part, you'll be going to practice about the creative visualizations to show disease incidence by demographics and also visualize clustering of patient risk groups. Here, one of the use cases is interactive dashboards for healthcare analytics. And after completion of this data visualization, you will be looking at machine learning fundamentals. In machine learning fundamentals, you are going to learn about the data pre-processing, that is cleaning, normalization, encoding, supervised learning, regression, and classification algorithms, unsupervised learning like clustering and techniques. In mission learning, after learning the theory part, you are going to be practicing on build an ML models to predict patient readmissions risk like classification and cluster patients by symptom similarity clustering. Here, one of the use case for machine learning is building predictive and segmentation models for in healthcare. And the fourth part you are going to learn in module 7 was ML flow, managing the machine learning life cycle. Here you are going to learn about the experiment tracking and metrics logging, organizing the projects and reproduce the pipelines. And also you will be learning about the model registry and version control, managing the deployment and life cycle of ML models. After learning this, you'll practice and track multiple experiments of your patient risk models, register the best model, and manage its deployment lifecycle. Here in ML Flow, the use case was the end-to-end ML lifecycle management for production readiness. This is about the module 7. Now we are going to learn about the module 8, that is, one second. Yes. Here in the module 8, we are learning about the DevOps, containerizations, and an APIs. That is, building, securing, and deploying scalable APIs with Docker and a Kubernetes. Here, like modern data engineering demands that you not only build a data pipelines, but also package, deploy, and secure them as a reliable services. This model covers about API development with Fast API and Flask, containerization with Docker, and orchestration with Kubernetes for scalable development deployments. Sorry. And here the real world scenarios are the imagine that you are at the data stream solutions delivering data services to clients. You are one of the Jira tasks assigned to you was develop a REST APIs to serve processed data using Fast API containerize the apps with Docker, deploy and scale using Kubernetes, secure APIs with JWT and HTTPS. Let's walk through building, securing, and deploying these APIs. Now, first, you are going to learn about the DevOps and an API development, that is, building RESTful APIs with Fast API and Flask. And later, you are going to be learn about the Open API auto-generated documentation, implementing security by using JWT tokens, HTTPS, API keys. After learning this theory part, you are going to practice about the creating of APIs that expose processed data endpoints, authenticate the request securely, and generates interactive API docs for clients. And here, one of the use case here is, for example, customer facing data services with secure documented APIs. And the second one you are going to learn in module 8 was the Docker, which is in a containerized applications. Here you are learning about Docker images, containers, volumes, and writing Docker files and managing multi-container apps with Docker Compose, and pushing and pulling images with Docker Hub. After completion of this learning part, you are going to practice on containerize your API apps and manage persistent storage using volumes. Use Docker Compose to spin up multi-service environments and publish images to Docker Hub for team sharing. Here, after completion of this practice session, you'll go through the use cases. One of the use case here is the consistent and portable deployment environments. And later, after completion of this Docker part, you'll be learning about the Kubernetes, which is in a container orchestration. Here, you'll learn about in container orchestration, Kubernetes architecture, pods, deployments, services, and deploying and scaling containerized APIs, managing secrets with config maps, monitoring and rolling updates. After you learn all this, you'll be practicing about deploying your Dockerized APIs to Kubernetes clusters and scale instances based on demand, secure sensitive information via Kubernetes secrets, and perform zero downtime updates. Here, one of the use case here is robust scalable API deployments in the production. This is about by the end of the module 8, you will learn building and securing REST APIs with the Fast API and Flask, containerized apps with Docker and manage multi-service setups, deploy and scale containerized applications using Kubernetes, implement production-grade security and monitoring for APIs. This module equips you to build a full-stack data engineer who can build, deploy, and maintain scalable, secure data services. This is about the module 8, and now we are going to learn about the module 9. Here in the module 9, you are going to learn about the CI/CD and monitoring. Here, that is the automating workflows, testing the code, and monitoring the data pipelines in production. Now, here you are going to build a data pipelines is just a part of your job. You must also automate workflows, ensure the code quality, and monitor production systems effectively. This module introduces tools and best practices for workflow, orchestration, version control, testing, and system monitoring. Here, one of the real-time scenario is, imagine you are a part of the FinTech Insights teams. Your Jira task assigned to you is orchestrate the ETL pipelines using Airflow, implement unit and integration tests for Python code, monitor pipeline health and Prometheus and Grafana. With the help of Prometheus and Grafana, manage the code repos and resolve the conflicts in GitLab. Now, let's explore these crucial steps in production readiness. Here, the first one, we are going to learn about the Apache Airflow, which is an workflow orchestration. Here in Apache Airflow, you are going to learn about designing the DAGs, using the operators and define the task, scheduling and monitoring the workflow via Airflow UI. Here, after learning this, you are going to practice about like building a DAGs that extract, transform, and local retail data daily, includes the failure handling and retires. and visualize the task data in Airflows and dashboards. Here, one after practicing this, here the use case was a reliable and transparent ETL orchestration. And later, after this Airflow, here we going to learn about the Python unit testing with the PyTest. Here, you learn about the writing unit test and integrations test, mocking dependencies and text fixtures, and running that test as part of CI pipelines. Here, you're going to practice like write a test for data validations, functions, API endpoint correctness, pipeline error handling. And one of the use case here is the ensuring the robust error-free data processing code and monitoring. And after completion of this Python unit test, you are going to monitor monitoring the data pipelines by using the Prometheus and Grafana. That is setting up Prometheus to scrape metrics, creating the Grafana dashboards to visualize the metrics, configuring the alerts on failures or anomalies. After learning all this, you are going to practice on monitoring the ETL pipeline metrics using track success or failure counts, visualize the resources, usage, and latency, set alerts for SLA breaches. Use cases is the proactive monitoring for data pipeline reliabilities. And after that, you are going to learn about the GitLab repository management. Here, you are going to learn about the managing the code repositories and branches, handling the merge conflicts and code reviews, using the Git blame and tags for track changes. Here in practice, you are going to learn about the collaborate on a shared repo, like resolve merge conflicts, tags table releases. Sorry, power was cut. I think so. There is a no net for me. Uh,